Now let's see this bottom up dynamic programming algorithm for that the same problem. First of all, LCS, longest common subsequence, x and y. So x and y are given in two arrays. So x is one DNA and y is other DNA, and now we have to find out the longest common subsequence. M equal to x dot length, which means we are finding out the length of m, and n equal to y dot length, we are finding out the length of y. And then let c equal to, we are creating a new array c 1 to m 1 to n. So what does it mean? We are creating a new table like this. That is what we have already seen, isn't it? So instead of c 1 to m and 1 to n, it is better you create it from 0 to m and 0 to n, so that you will have even zeros, right? So it is nothing but we are just creating it like this: 0 1 2 3 0 1 2 3, right? Just the same as the previous one. And then for I equal to 1 to m, I comma 0 equal to 0. So what is that they are doing is, this everything is made 0. And then for j equal to 0 to n, c of 0 comma j equal to 0, which means this entire part is made 0, right? And for I equal to 1 to m, j equal to 1 to n, so they are keeping on computing one by one. So for I equal to 1 to n means they are going in row major order, row major order, row major order, row major order, right? And look at the code. If there is a match, in case if there is a match at any point, then 1 plus the diagonal value. If there is a match at some point, 1 plus the diagonal value, that is what they are doing. If there is no match, then what is that they are doing is, if there is a match, then it is what they are doing. Else means if there is no match. See this, see in all the algorithms which I have written, you just look at the indentation. Indentation means I am writing some code inside some code. So this means that there is a for loop, inside which there is one more for loop, inside which there is if, and inside this there is this statement. So this statement is actually the for loop and if loop, right? Sorry, if statement. So you just look at the indentation and understand where it is. So these two are going to say that we are going to traverse the table one by one in row major order, one element by one element, which means here like this, row major order. And then at every element, what is that they are doing is they are comparing. In case if they are equal, so if they are equal, they are just adding 1 plus this one. So at any point, if you see any value as equal, they are just taking the diagonal element and they are adding 1. Else means if they are not equal, then what is that they are doing is take the maximum of these two elements, in case if you are standing here. Like that, the entire thing is computed and finally it is returned. So just look at the time complexity. Time complexity for this algorithm is, you are going to fill all the entries, and how many entries are there? Order of m into n entries are there, right? Where m is the size of x and n is the size of y, and every element has to be filled. And whenever you are filling any entry, it is simply a constant amount of code, right? So for this, the time taken is constant time, so you can write it as order of 1. Therefore the time complexity taken is order of mn. What about the space complexity? For this table, the space complexity is again order of mn. Why? It is a kind of array, right? And now you need not implement it in the bottom up manner, you could even implement it in the top down manner. In the top down manner, when you implement it, then you are going to use recursion. In that recursion, whenever you are making a call to a function, just see if that value is already present in the table. If the value is not present in the table, then you compute it. There also the time complexity is going to be order of mn. The reason is the number of unique subproblems are going to be order of mn, and at every subproblem the time taken is constant. Therefore overall time complexity is order of mn. If you use top down memorization method like in matrix multiplication, not required, I'm just telling you that you could even do that, right? It is a beautiful algorithm, you need not spoil it, right? And in case if you are using that top down algorithm, what happens is, along with the table which is going to take order of mn, you need to even use a stack which will be as big as m plus n, that is an extra space, and it doesn't look beautiful. Also the code, this is a beautiful code, right? You can follow this, and yeah, this is the algorithm and this is the time complexity. Fine, let's stop it here. Okay.